Today we discuss the topic blackbody radiation. Radiation is wave consisting of oscillating electric and magnetic field called electromagnetic waves. Frequency nu is equal to c upon lambda. C is the speed of light. Lambda is the wavelength. Then the wave number nu bar is equal to reciprocal of wavelength. The experimental observations of blackbody radiation cannot be explained by classical mechanics. An ideal body that absorb and emit all frequencies, that ideal body is known as the black body. When stove burner is heated first, it turns dull red. And further நம்ம temperature ரைஸ் பண்ணும்போது dull red turns dark red மாறும். இன்னும் temperature ரைஸ் பண்ணோம் அப்படின்னா ஒயிட் கலர் டர்ன் ஆகிட்டு ஃபைனலாக அந்த பர்னர் ப்ளூ கலரில் எரிகிறத நம்ம பார்க்கலாம். இதிலேருந்து நம்ம என்ன தெரிஞ்சுக்கலாம்? As the temperature increases, the frequency increases. Red color is the lower frequency than blue color in the region. As the temperature increases, the frequency of radiation increases. As the temperature decreases, the frequency of emitted radiation decreases. Radiation emerging from the small hole called blackbody radiation. It depends only on temperature, not the nature of the solid. Distribution of energy. Radiation emitted is not a single wavelength but spread over a wide spectrum of wavelength. Max Planck derived the blackbody radiation law. Many classical physicists என்ன பண்ணாங்க, ட்ரை பண்ணாங்க blackbody radiation experimental observation explain பண்றதுக்கு ட்ரை பண்ணாங்க, பட் எல்லாமே unsuccessful முடிஞ்சது. Many classical physicists tried to explain the experimental observation of blackbody radiation, but it could be unsuccessful. Then Max Planck derived the blackbody radiation law. From the graph, the intensity versus frequency, two types of curves are obtained. The dashed curve is the prediction of classical mechanics due to the Rayleigh-Jeans law. Del ft into df, that is equal to 8 pi kt into f squared upon c cube into df. These curves are obtained from experimental observations of blackbody radiation. As the graph, the temperature increases, the frequency is also increases. But the classical mechanics of Rayleigh-Jeans law, only at low intensity and low frequency it will be obeyed. But the frequency increases, the Rayleigh-Jeans law will be failed. Energy of oscillators had to be proportional to an integral multiple of frequency. E is equal to nh nu. N is the whole number, h is the Planck constant. The value of Planck constant is 6.626 into 10 to the power minus 34 joule second. Max Planck finally ஒரு equation derive பண்ணிருக்காங்க. Del ft into df, that is equal to 8 pi h into f cube upon c cube into df upon e power hf upon kt minus 1. This equation is the Planck distribution law for blackbody radiation. In this equation, del ft into df is the density of radiative energy between f and f plus df. C is the speed of light, 3 into 10 to the power of 8 meters second power minus 1. This equation gives good agreement with the experimental data for all frequencies. Then the blackbody radiation related இருக்கக்கூடிய problems நம்ம அடுத்து பார்க்கலாம். இந்த problem PG-TRB 2013 இந்த question கேட்டிருக்காங்க. blackbody radiation வந்து கேட்கப்பட்ட கேள்விகள். The radiation density of blackbody radiation calculated by Planck is 4 ஆப்ஷன்ஸ் கொடுத்துருக்காங்க. இந்த 4 ஆப்ஷன்ஸில் இப்போ நம்ம பார்த்த டாப்பிக்கில் blackbody radiationல ஃபைனலாக ஒரு ஈக்குவேஷன் பார்த்தோம் இல்லையா, rho into v that is equal to 8 pi h nu cube upon c cube into d nu upon e power h nu by kb t minus 1. This is the correct option for this question. Next problem number 2. Calculate the magnitude of the energy of the photon associated with the light of wavelength 6057.8 Armstrong. The 4 options are given. கொஸ்டின்ல என்ன கேட்டிருக்காங்க, எனர்ஜி கேட்டிருக்காங்க, வேவ் லென்த் கொடுத்துருக்காங்க. then the formula E is equal to h nu. E is equal to h into c upon lambda. The value of h is 6.626 into 10 to the power minus 34 joule second. The value of c is 3 into 10 to the power of 8 meter second per minus 1 upon the wavelength is 6057.8 Armstrong is 10 to the power minus 10 meter. E is equal to 3.3 into 10 to the power minus 13 joule. So the correct option is B. Next question, problem number 3. Calculate the frequency of wavelength is 400 nanometer. Then the four options are given. Then the solution, frequency calculate பண்ண சொல்லிருக்காங்க, wavelength கொடுத்திருக்காங்க. So nu is equal to c upon lambda. Value of c is 3 into 10 to the power of 8 meter second per minus 1. Lambda is 400 nanometer 10 to the power of minus 9 meter. Then 0.75 into 10 to the power of 15 second per minus 1. Nu is equal to 7.5 into 10 to the power of 14 second per minus 1. So the correct option is A. The value is 7.5 into 10 to the power of 14 second per minus 1. Next question number 4. In explaining blackbody radiation, Rayleigh-Jean's law is failing at option A, high frequency, option B, low frequency, option C, low intensity, option D, high wavelength. Out of the four options, the correct option is high frequency. நம்ம இந்த லாஸ்ட் கிராஃப்ல பார்த்தோம் இல்லையா, Rayleigh-Jean's law only failed at high frequency. It obeying at low frequency, low intensity. So B option கிடையாது, C optionும் கிடையாது, D optionும் கிடையாது. ஏன்னா E is equal to h nu. Then the nu is equal to c by lambda. Nu is inversely proportional to lambda. So the frequency is increases, lambda is decreases. So low frequency and high wavelength is the same. So in this question, the correct option is A. Okay, thanks for watching. இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்தா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, சேனலை மறக்காம சப்ஸ்கிரைப் பண்ணுங்க, கூடவே பெல் ஐகானை கிளிக் பண்ணுங்க.